It does not have a log in it. It's an exponential form. So there's a couple different things that we can do. Okay? If we have the same base, we could set the exponents equal, but we don't have the same base. So we have to use something called logging both sides. So in this case, if we have a base of e, what log do we use? Do we use ln or do we use log? Ln. Okay, so we're gonna natural log both sides. Okay, so it just means put the ln in front of both. Now, what is the base of the natural log? What's the base of a natural log? E. Okay, E. So technically both of these have a base of E. That doesn't really affect this side. But over here, when we have a base of E, okay, and we're taking the log of E, those cancel each other out. Okay, so these are gone and we're left with 2x. So that's a rule to remember. When you take the natural log of E, see you later, you can get rid of the natural log of E. So we're left with the exponent there. And then here we still have our natural log of 5. Okay, now if I'm solving for x, I would divide by 2. So we have natural log of 5 over 2. So I'm going to open up my calculator. Then we're going to put this in and get a decimal. We will have to round to 3 decimal places. I'm going to show you how to check your answer here. So natural log is right down here under regular log. Okay, and we do 5. Now you're going to notice when you press natural log, it's going to put a parenthesis in there for you. You have to end that parenthesis before you hit the divided by 2. Okay, so you should get about 0.805. We'll say 0.805. Okay, now I'm going to show you how to check this. Okay, we're going to see, does e to the 2x actually equal 5? Okay, so e to the power is right here. So you'd press second and then the natural log, and it'll give you e to a power. And so that power is 2 times x, and we got 0.805, for x. Okay, we get about 5.00 something. So it's 5. Okay, now why is this rounded and it's not exactly 5? Because we rounded our original answer. Okay, so if we were to use our original answer, it would have been 5. Okay, but because we rounded, that's why we have all these extra decimals. But as long as you look in those couple decimal places or zeros, here we go. Okay, so our answer was here. We checked it by plugging it back in. Questions for me? Okay, number 2. Okay, this one already has the log in it. We talked yesterday about rewriting into exponential form. Okay, so we're going to rewrite this. We're going to do 3 squared equals 4x minus 7. So we're just going to rewrite it. Okay, we can simplify this, the 3 squared. Easy to solve for x from here. We'll add 7 to both sides and divide by 4. Again, you could plug that 4 in and check your answer, and you should get 2 when you put this whole thing in when you plug in 4 for x. What questions do we have? Okay, number 3. Okay, we have the log already in there. This is different. Okay. Well, no, it's not different. It's the same. Sorry. Okay, same thing as we just did. What's the base on e? Okay? Or based on E, based on ln. Oh, no, sorry. Okay, based on ln should be E. Okay? There's two different ways to do this problem. We can rewrite it into an exponential, right? We would do e to the 8th equals e to the 2x, negative 2x, okay? Or, okay, we just talked about, if we have ln base e of e, what can I do here? Cancel. So if I cancel them, I'm left with negative 2x equals 8. Well, guess what? If I have the same base, I can drop the bases. So either way you do this problem is totally fine. Okay? You're going to get the same answer because you'll divide by negative 2, and you'll get negative 4. Okay? So either way you do it, it's not wrong. All right, number 4 is different. What is different about number 4? We haven't seen it in the last 2 problems. 2 logs. There's a log on each side. Okay, so here is another rule. If you have the log on each side and the bases are the same, what are the bases of these logs? If we don't see a base, what do we assume for regular log? 10. Okay, this is the common log. So we technically have bases of 10 there. We can drop the logs. Since they're both the same on either side, we can get rid of the logs. So we're left with 5x equals 2x plus 9, solve for x. Okay, so once you figure out what you need to do to the original problem, it's just solving for x. Okay, once you get that first part done, just solve it for x. Do you need me to go back? Good? Okay, any other questions? Anybody need me to go back anymore? All right. Number 5. Okay, this one deals with a different rule. If we have a number in front of the log, does anybody remember what we can do with this number? I know algebra 2 has been a little bit ago. Anybody remember what this can do? Where it can move to? It's your exponent. Okay, so you can actually rewrite it like this. So basically what happens is you take that 2, and it was actually originally an exponent on the negative 2x. It is crucial that you put those parentheses around that negative 2x, because that square is applied to everything inside. Okay, we're going to rewrite this because we have a log on one side that's not really helping us. So we're going to do our rewrite. So 7 to the 0 equals negative 2x squared. What's anything to the power of 0? 1. You guys sound a lot better than first period because they were negative 0. Okay, so we have our negative 2x. Okay, now if we want to solve for x from here, how do we get rid of the square? Square root both sides. Okay, and I bet from here you know how to get x by itself. Divide by negative 2. So you should get that equals negative 1. Questions? Okay. All right, number 6. There is something weird on number 6. What looks like it's out of place? What's out of place on number 6? Yeah, that negative 10 at the very beginning. Just kind of hanging out there. We don't really need it there, so let's add it to the other side. Okay, because it's kind of in the way of us working with that logarithm. Okay, and we end up with 0. That's okay. That can happen. Don't be scared of 0. Okay, now, from here, what would you do? Can we solve with the log there? No, what do we need to do? Put it in exponent form, exponential form. Okay, so do 3 to the power of 0 equals x plus 3. Okay, 3 to the 0 is 1. Subtract out that 3, you should get x equals -2. Okay, question so far? The next two bring in a couple new properties. Okay, so we're going to talk through those, and then I'll have you do some practice. Okay, so ready. All right, so number 7. Okay, what do you notice that's different about number 7? We haven't had this yet. 2 logs on the same side. There's addition in between. Okay, so when there's addition in between 2 logs that have the same base, that is the important part. Okay, there may be 2 logs on one side, but they have the same base. What's their base? 10. Okay, so since they have the same base, if there is addition in between them, addition means multiplication. Here's what I mean. You can take both logs and condense them into one log. Okay, that's a rule that you should have learned when you did logs. Okay, so now we're going to have one log. The base is still 10 there. You don't have to write 10, but you can. Okay, then when I say multiplication, here's what I mean. You take the insides, x and 8, okay, and you multiply them. So when it's addition, you multiply the inside, so 8 times x. Okay, we keep the right side exactly the same. So we just condensed those 2 logs into one. And we could do that because of the addition sign. Tracking with me on that part? Okay. From here, can we solve with the log? No, what do we have to do? Exponential. Rewrite it. Okay, what's the first thing that you need to simplify? 10 squared is 100. Okay, divide by 8. Okay, you can give me the simplified fraction, 25 over 2, or you can give me the decimal 12.5. Doesn't matter to me. Questions on that part? Okay, the last one, number 8. Okay, something new again. What do you notice is different about this one compared to the last question? Subtraction. If addition means multiplication, subtraction means division. Okay, so the key is that they have the same base. If they don't, that's a problem. Okay, but these have the same base. So we have log base 9. Okay, you're going to take the inside parts and divide them. Okay, so whatever comes first goes in the numerator. Is that a plus? Yeah, x plus 6. Okay, and then over x. So you just take those inside parts. Whatever comes first is your numerator. Whatever comes second is your denominator. Right-hand side stays the same. All right, take a look at number 4. And number 4, what rule did we use? They cancel. What cancel? Yes. If they are the same log with the same base on each side, get rid of them. Okay, so here we can get rid of our logs and we're left with just the inside part. Okay, that makes solving so much easier. Okay, if I want to get x by itself, what do you think would be my first step? Multiply by what? Yes, we don't want to work with fractions. Okay, so get that x out of there, multiply by it. Okay, and then I would subtract this x. There are practical backs. Go and flip it over. I'm going to tell you a couple things. Okay, there's the first set of problems. Those are strict. Yes. What do you mean? 2x minus 1x.
Oh.
Is that what you meant?
Yeah.
Yep. 2x. Okay. So the first two problems on the back are fine. The second two problems, so that second line. Okay, this second line right here. Okay, where one of them says log base 8 of x, the other one says log base 6 of x. These are a little bit more difficult. Okay, let me explain. When you solve those, you will get a trinomial. Something that looks like that. What's different about this than what we had here? Or any of our other problems? What's different? Did we ever have an x squared in our answers? No. Okay, when you have an x squared, this means you have to factor these. Okay, guess what? I'm not going to make you factor. Go to Desmos, put whatever you get, whatever your answer is, put that in Desmos, see where it crosses the x-axis. Those are your answers. Okay, you'll see up here, okay, I put the answers up here for you, so you can check yourself. Okay, you will find these in Desmos if you did that properly. Okay, if you have questions, you let me know. I will never quiz you on those two types of questions. Those are just like challenge questions. Okay, but everything else, hopefully, you should be able to solve. Okay.